Class, we are going on to the next section. I will go through exercise 17.3 with you. Now, for this particular exercise, I'm not going to do all the steps. Some of the steps you have to do it by yourself because I think you can manage by now. Okay, so let's take a look at exercise 17.318. They want us to find the coordinates of P and Q, and after that find the area of this particular region. So, in order to find the coordinates, I solve these two equations simultaneously. So I can find P as 17 and Q as 37. Now the area shaded will be this rectangle minus the area under curve. So rectangle minus area under curve, I will get the correct answer as 1/3 unit square. Now if you do not want, you want to integrate 7, is also okay because this is the equation of the line. So you can integrate from 1 to 3, 7 to get this answer 14 as well. Okay, like I said, it's up to you and for your preference. Okay, whichever you like it, you just do it. Alright, now next, 1b. I need to find the area of this particular region. Okay, I solve simultaneously. I get P as 15 and Q as 55. Now in order to find this particular shaded region, I need to take area under the curve minus this rectangle. So area under the curve minus rectangle, I manipulate, I will get 10 2/3 unit square. Okay, like what I've said, in order to get this, you can also do it by integration of 1 to 5 dx. You will also get 20. Now let me just show it to you. You will have 5x 51. You will get a 25 minus 5. You will get a 20. Can you see, if I integrate this, I will also get 20, which is the same as the area of the rectangle. So it's up to you to use whichever method that you're comfortable with. Okay, now next we go on to 1c. Now 1c is a bit troublesome because the solutions involve surds. Okay, and this one, the curve is in the form of x equals to something. Now I'm integrating with respect to the y-axis, so it has got to be dy. Okay, and x is already in terms of y. So in order to find the coordinates of P and Q, I need to solve the equation simultaneously. I will get these two values. That means coordinates of P will be this and coordinates of Q will be this. So area of this shaded region will be the rectangle, which is 2 times 2√2. 2, this length here is 2√2 minus this particular area, this area, and this area. Okay, 2 minus √2 to 2, I integrate. 2 to 2 plus √2, I integrate. So you manipulate accordingly, you will get the answer as 8√2 over 3 when you do the integration properly. Now, I know some of you will be wondering, how come I integrate from here to here and then from here to here? Okay, because I want the area here, so I integrate from here to here. I want the area here, I integrate from here to here. Now, some of you will be asking if I can integrate straight from here to here. The answer is yes for this question, because the area under the curve is continuous. So it is here to here and this one is connected. So when you integrate from 2 minus √2 to 2, 2 to 2 plus √2 actually is a continuous thing. Actually you can just integrate from here, this part to this part. The answer will also be the same. So it doesn't matter. But for me, I would rather that I want to see the boundary, so it means from here to here, then another one from here to here. So I will do it separately. If you do it continuously, you are also okay for this particular question. Alright? Okay, now next we go on to 2b. 2b will be a trigo expression. So you want to find the area shaded, you got to find the area under curve minus the area of this rectangle. So I will solve this simultaneously to find the x coordinate. I'll find basic angle. Okay, because sine is positive, it will lie on the first and the second quadrant. So I find it accordingly. Now I integrate from here to here. Then I minus the area of this particular rectangle here. Okay, so I manipulate, I will get this final answer. Okay, alright, so that will be for your question number 2. Okay, now we move on to question number 3. They want to find the area of A and the area of B. Now before I do that, I need to find the coordinates of these 2 points of intersection first. So I equate these two equations. I will find x4 and x2. That means this is 2 and this is 4. And in the question, they already told you this is 1. Now how to find area of A, this shaded area, is the curve minus the line. So 1 to 2 curve minus line. Okay, so I will not do the steps. You will do the steps. You will get 1/3 unit square. Now can you see that for this case here, I didn't find the trapezium. I used the line instead, because for this one it's quite inconvenient for me to find the coordinates of the y-axis, of the y coordinates, the y coordinates, because it's quite tedious. So I just do the integration. I'll get the answer as the same. It's perfectly fine. So that's why just now I said it depends on the question whether you want to do it by integration or you want to do it by shape. It's also okay. It doesn't matter. Okay, now next we go on to the next part. We are going to find the area of B. This time round is the line minus the area curve, then you get B. So I'm going to show you the working here. So you will integrate from 2 to 4 line minus integrate 2 to 4 curve. You do the necessary working and then you get 1/3 unit square. Alright. Next, we will go on to question number 5. Question number 5 part 1 says that you are to find the coordinates of A. That means I need to find the coordinates of A. In order to find the coordinates of A, I need to find the equation of the tangent. So I differentiate, I substitute in, I find the equation of the tangent, which is this value, which is this equation. And when I plug in y equals to 0, I will get your A as 2,150. A as 2,150. Okay, then part 2, they want you to evaluate this particular expression. So you will do the necessary integration and you will get this answer, 15/1/3. That means you integrate, I think I make a mistake in my writing here, is 3 to 5. Evaluate 3 to 5. I wrote wrongly. This should be 3 to 5. Okay, let me double check. Evaluate integration 3 to 5. 3 to 5, okay. You will get a 15/1/3. Okay, please amend this. Alright, now the area required, the area shaded required here. Now all of you look here. The area required here will be the area of this triangle minus the area under the curve. Okay, now can you see that the area under the curve here is you integrate this from 3 to 5. Now actually this is the answer already. There's no need to integrate again. So the area required will be the triangle area. This is the triangle minus whatever we have found here, because this is the area that is shaded here. It will leave you with the green area. So when you minus off, you will get a 4/15 unit square. Okay, 4/15 unit square. Alright, so this will be the answer to your question number 5. Alright, now we move on to the last question. That is question number 7. Okay, let's look at question number 7. Now, first of all, they want us to find the value of K. Now, we know that P falls on the curve, so we substitute in the coordinates of P. 2, 0 into the curve, we will get K equals to 2. Next, find the area enclosed by the curve and the line OQ. Now, first of all, I want to find the value of H first. So, this is already the equation. I know that K is 2. When X is 3, what is H? So it's -3, so H is -3. So I know the coordinates of Q is 3, -3. Okay, now area of A on top is integrate 0 to 2, this expression. I will not go through the integration. You integrate, you will get this answer. Okay, now area of B. Now all of you look at this area of B here, that's below here. Now, do you agree that area of B here is actually the triangle here? Okay, the triangle here minus area over here, the area of C. Now, The triangle is no problem. Half times 3 times 3. That will be the area of triangle. Half times 3 times 3. Now how to find the area of this region here? You integrate the curve from 2 to 3. 2 to 3, the curve equation. But you must put a negative because this area is under the x-axis. Okay, or below the x-axis. Alright, so you got to put a minus. So when you manipulate, you will get the answer as 316. So the total area required will be, you add up these two, 1 and 1/3 and 316, you will get a 4.5 unit square. 4.5 unit square. So I want to repeat the last part here. In order to find the area of B, I take this triangle minus area here, the small area C here. And this small area C is area under this curve. Can you see this curve here? I integrate from 2 to 3. I find this area, but must remember to put minus because it's below the x-axis in order to get the correct answer. Then finally, you must add these two answers up to get the final solution or the area of A plus B. Because the question say, find the area enclosed by the curve and the line OQ. Okay, find the area enclosed by the curve and the line OQ, which means it is the area of A plus B. Alright, so this will complete the exercise 17.3. Okay, any questions you will ask me during the next lesson. Thank you, class.